Hello students, here is the quiz on motion in two dimensions. So the first question, you want to swim straight across a river that is 76 meters wide. You find that you can do this if you swim at an angle of theta is equal to 28 degrees from the upstream direction at a constant rate of 1.4 meter per second relative to the water. At what rate does the river flow? The angle theta is measured from the river bank. That means directly upstream is 0 degrees, while directly across the river is 90 degrees. So you can see that the angle is taken in a particular way here. So let me go to that diagram. So this is question number 1. Okay, so look at the width of the river, 76 meters. And the angle is taken with upstream. So the water is flowing downstream like that. But the water, all right, let me try to show it with this, all right? The water is flowing downstream this way. The angle is taken with the upstream. So that's why this angle is 28 degrees. So if that angle is 28, then this is also 28 because they are alternate angles. And you're asked to find the velocity of the water, which is flowing down that way. Okay, that's what we're trying to find. So if you look at the right angle triangle, you see that cosine of 28 is BC, which we're trying to find, over AB. And AB is 1.4 meter per second. That's given. Therefore, simple math, cosine 28 is BC by AB. You rearrange that. BC is AB cosine 28. And AB is 1.4, so 1.4 times cosine 28 is 1.2 meter per second. So that is the speed or the velocity at which water is flowing. So, and then you go to question number 2. Okay, here's the question. A hockey puck slides off the edge of a table, that's better, with an initial velocity of 26.0 meter per second and experiences no air resistance. The height of the tabletop above the ground is 2 meters. What is the angle below the horizontal of the velocity of the puck just before it hits the ground? So here's the diagram. This is the height of the table, which is 2 meters, and the puck slides off the edge at 26 meters per second. You know that the horizontal velocity is not affected by gravity, so it remains constant, and right before hitting the ground, it is still 26.0 meter per second. But when you look at the y velocity, the vertical velocity, it started off at 0 here, and then it keeps increasing because of the acceleration due to gravity, and it becomes something just before it hits the ground. So we need to find what that something is. In order to find that, we have to use this kinematic formula. So right here, Vy squared is Vo squared plus 2Ay. The initial is 0. And then you plug it into that. 2 times negative 9.8 times negative 2. That's delta y because it's coming down. And when you do that math, you get 6.26 meter per second. So once you have V sub y and V sub x, you see that triangle there. And from that triangle, tan theta is opposite side by adjacent side. So that's what I've done here. And when you do the calculations, you get 0.24. Take the tan inverse of that, and you get 13.5 degrees. So that is the angle below the horizontal. See, that's the angle below the horizontal at which it hits the ground. Now, number 3 is a conceptual question which you should have answered. So here is number 4. An airplane flies between 2 points on the ground that are 500 kilometers apart. The destination is directly north of the origination of the flight. The plane flies with an airspeed of 120 meter per second. If a constant wind blows at 10 meter per second due west, what direction must the plane fly relative to the north to arrive at the destination? So the diagram is important in this case. So we see that the distance between A and B, so the plane is trying to fly from A to B. B is directly north of A. The distance is given as 500 kilometers. We don't even need that distance to figure out this case. Now, this is the wind blowing due west, and that's why the airplane has to go in this direction, so that the combination vector of this velocity with this velocity gives you the velocity along AB. So that's where you have the triangle from. And therefore, we know if this angle is theta, which we're trying to find, then you know from this that cosine theta, sine theta, actually if you take sine theta, which is this part, sine theta is BC over AC. So we're talking about velocities, so 10 divided by 120 will give you sine theta. That's what I've written here. Sine theta is 10 over 120. Find that, take the inverse of that, and you get 4.7 degrees east of north, because going that way is east, starting from north, right? Starting from north, going east. So that is the answer. We did not even need the 500 kilometers to do that. In the next question, an electron moves with a constant horizontal velocity of 3.0 times 10 to the power 6 meter per second. That's really fast. And no initial vertical velocity. So it has a constant horizontal velocity but no initial vertical velocity as it enters a deflector inside a TV tube. The electron strikes the screen after traveling 13.0 centimeters horizontally and 58.0 centimeters vertically up with no horizontal acceleration. What is the constant vertical acceleration provided by the deflector? The effects of gravity can be ignored. So in this case, the forces are electric forces, and therefore the acceleration is due to the electric force, so we're not considering gravity. But the diagram is again important. So you have these two plates, the deflecting plates, and normally between them you have a voltage setup, and that voltage is responsible for deflecting the electron. So here is the electron coming in with just a horizontal velocity and zero vertical velocity initially. But as it enters the electric field, because of the continuous force acting in the y direction, now remember that's the y direction, because of that, the electron is deflected continuously in the y direction. So by the time it reaches here, the deflection is 58 centimeter and it has traveled 13 centimeters. That's what is given. So what we will do is, because we know that this velocity is constant and we know the displacement, we can find the time it takes to go from there to there just using the x component. So you know time is displacement over velocity. See that? And you've got to change this into meter, which I've done here. Divide by the velocity and you get this very small time. Once you get that small time, we can figure out the acceleration, because we know delta y is 58 centimeter. So using the kinematic equation given here, we can find out the acceleration, because we know this, that's delta y in meters. And then this is 0, remember, initial vertical velocity is 0. So the whole thing became 0. And then you have 1/2 a sub y time squared. We got the time from there, plug it in, make a sub y the subject, calculate, and you get 6.2 times 10 to the power 14 meter per second squared. I know this is really high, but this is the magnitude of the acceleration of an electron in a television picture tube. Then we have one of the easier questions. A small boat is moving at a velocity of 3.42 meter per second when it is accelerated by a river current perpendicular to the initial direction of motion. If the acceleration is that much, what will be the new velocity after 34.2 seconds? So here again, there is an x velocity which does not change, but the y velocity has an acceleration. So that means it changes. So first what we do is we find the y velocity using kinematics. The initial y velocity is 0. The acceleration, the y is given. Time is given. Find out the final y velocity using this equation. Okay, and then that's 0. That's why you don't find that. So that's a times t right there, a times t, and you get it. Once you get it, you can complete the triangle. Now we know the y velocity is 25.7. The x is 3.42. And how do you find the magnitude? Square both of them, add them, take the square root, which when you do, you get 25.7 meter per second. Excuse me. And to find the angle, tan theta is opposite by adjacent. So do that and you get the number, take the tan inverse, and you get the angle, 7.59 degrees. That's how you do that. Okay, that brings us to number 8. An electrical motor spins at a constant 2128.0 revolutions per minute. If the armature radius is 5.058 centimeter, what is the acceleration of the outer edge of the armature? So when something is spinning at a constant rate, the acceleration that we have is called the centripetal acceleration. And the centripetal acceleration is given by v squared by r. So that's a formula for centripetal acceleration. Velocity squared by the radius. So the radius is already given to us. We need to find the velocity and plug it into that formula. Now to find the velocity, first we have to change the revolutions per minute to revolutions per second. Because 1 minute is 60 seconds. Divide by 60, you get RPS, which is revolutions per second. Once you get that, and this is the radius, velocity is r times angular velocity, omega. So I've not written that, but writing it with this mouse will be tough. Velocity is r times omega. Omega is angular velocity, but omega is also 2 pi times frequency. Why? Because for each rotation, the angle is 2 pi radians, isn't it? 360 degrees, 2 pi radians. Makes sense? So r times 2 pi f. So that's what I have substituted there. R times 2 pi f, but it has a square, so there is a square there. And then divide by r. Remember, you got to square all of these terms, and you're going to get r squared and on top r in the numerator. So one of the r's gets cancelled. Then this becomes 4 pi squared f squared r. So that's what I've done, and plug everything in. You get the acceleration as 2,512 meter per second squared. Should make sense. All right, bringing us to number 9. A hobby rocket reaches a height of 87.4 meter, lands 132 meter from the launch point with no air resistance. What was the angle of launch? Now, for ground to ground, so when something starts from the ground, something starts from the ground and ends up on the ground, we have some ready-made formulas that we can use. For maximum height, here is the formula. V squared sine squared theta by 2g. For range, now range is the maximum x distance. This is the formula. So since these two are given, I'm just going to use those two formulas. But in the formula for range, you have sine 2 theta. See that? Sine 2 theta can be written as 2 sine theta cosine theta. Yes. So that's why I've broken it up into 2 sine theta cosine theta. And then what I do is I divide the left-hand side by the left-hand side and the right-hand side of this equation by the right-hand side of this, which you see down here. H over R, and then when you divide, you know that you invert it and multiply, right? So that's what I've done. So I have held this the same, which you see here, and then this one I have inverted it. So G is in the numerator, all of this is in the denominator. And when you do that, you see that many terms get cancelled, as you can see, and then one of the sine theta from here gets cancelled with the square. Because square means sine theta times sine theta. And so what do you have remaining? You have sine theta, and then you have 2 and 2 here, which is 4, and cosine theta. Now we know sine theta over cosine theta is tan theta. So that's 1 over 4 tan theta. And what are we looking for? We're looking for theta. So let's make tan theta the subject. The 4 will go to the other side, so it will become 4h by r. And so 4 times the height divided by the range, and you get, when you do the calculations and take the inverse, you get 69.3 degrees. So that's how that is done. All right, coming up the last one, which is again a good one. Okay, let's see. A rock is thrown at a window that's located 18.0 meters above the ground. The rock is thrown at an angle of 40 degrees above the horizontal. The rock is thrown from a height of 2 meters above the ground. That's a speed, 30 meters per second. And it strikes the window on its upward trajectory, means while it's going up. Because in a parabolic motion, you can have it going up and coming back down, okay, like that, going up, and then after it goes up, it comes back down. So it says that it strikes it on the way up, and you got to find the horizontal distance, which means you're looking for delta x. Okay, so the diagram is important again, and here is the diagram. 2 meters above, that's 2 meters. The window is 18 meters above the ground, which means the delta y is 16 meters, right? The stone has to travel 16 meters. It's projected at 40 degrees. So first thing is you break that velocity into its x and y components. I've written down the y components first. Delta y is 16 meters positive because it's going up. A is negative 9.8, and then the initial vertical velocity is v naught sine theta. So 30 sine 40, which comes out to be 19.3 meters per second. And then you can find the time. This is the kinematic equation which we're going to use. So substitute carefully, and then this is 19.3 t, and 1/2 times negative 9.8 is negative 4.9, isn't it? So that's how we get that. To rearrange it, you get a quadratic equation using the quadratic formula, minus b plus or minus square root b squared minus 4ac by 2a. I've done that. You get two numbers, both positive. So time cannot be negative, but in this case, both are positive. And since it's given that it strikes it on its upward trajectory, we go for the smaller time. Because the up trajectory comes before the lower one. See, it doesn't strike it on the way down, strikes it on the way up. So take the smaller time, and then we know that delta x is Vox multiplied by t. So the horizontal component of the velocity is 30 cosine 40, which is 22.98, and then 22.98 times 1.19 comes out to be 27.3 meter. That's it. That's how you do these problems. I think I finished this video in about 20 minutes. I hope you understand the ideas that we're using. There's no use of memorizing it. This is motion in 2 dimensions. So you got to separate the X and the Y. And diagrams are very important. And this will help you prepare for the exam. Thank you.